In the rich fishing grounds off Peru, deep ocean currents are driven upwards as they near the South American landmass, bringing a richness of nutrients with them. Phytoplankton. Microscopic plant organisms make dramatic use of the nutrient-rich water and sunlight. Carbon dioxide is dissolved from the air, giving these tiny single-celled creatures all they need to thrive and reproduce. Now they multiply in their billions. What started as a small patch of plankton proliferates exponentially and can soon be seen from high above. Within just 24 hours, 500 square kilometers of ocean turns from blue to green. The plankton bloom triggers one of the largest feeding frenzies on the Earth. Similar upwellings of nutrients around the world trigger more plankton blooms. Plankton blooms, seen here as vast ribbons of green, can cover as much as 1/5 of the planet's oceans. Plankton is the base of the food chain that conveys the Earth's minerals directly to the billions of tons of living things in the oceans. Minerals that have spent millions of years circulating inside the Earth now form the building blocks of marine life. Within a further 24 hours, the plankton that have not been eaten sink back down into the abyss. They take the carbon and minerals they have ingested with them, all the way to the ocean floor. Here they will stay for many millennia, a thick covering of tiny carcasses up to 1 kilometer deep. Eventually, many will re-emerge in the next step of the system and provide the vital chemicals needed to continue the chain of life on land. It's May, the height of the dry season. Camel herders travel through one of the most exposed regions of the Sahara, an ancient inland sea that dried up 5,000 years ago. The Bodele Depression. The ground beneath their feet, called diatomite, is made from the ancient corpses of plankton. It's rich in compounds of iron and phosphorus, two elements needed by all known living organisms. More remarkable still, these very grains of sand will in just 6 days' time breathe life into a tropical rainforest 5,000 miles away. It takes just one flake of diatomite to lift into the air to start the process of rebirth. The flake fractures into a fine powder that's carried off by the wind. Soon, more microscopic flakes fill the air. This visualization, made with data from a satellite called Meteosat, reveals a daily pulse of dust. Here it's shown as a cloud lifting from the desert. The dust rises with an almost clockwork precision at noon each day. What started as a microscopic process is now a vast dust storm. It's 100 stories high and several hundred kilometers wide. The cloud of ancient plankton is now blown across Africa. At the west coast, the dust is drawn upwards high into the sky and begins an epic voyage across the Atlantic, carried by the prevailing wind. Satellites reveal that 54,000 tons of dust is transported 8,000 kilometers to the Amazon in a single day. It's here in these clouds, high above the rainforest, that the ancient plankton is reborn in spectacular fashion. The minerals in the dust dissolve into water droplets. It falls onto the Amazon with the rain. Precipitation falls incessantly throughout what is now the Amazonian rain season, delivering a total of 40 million tons of African dust into the forest below. The fertilization of the Amazon by Saharan dust remained invisible to humans until the advent of a satellite called Terra. Terra's instruments are so sensitive, they can not only observe the dust migrate to the Amazon, they can measure the growth of the canopy from space. It's possible to watch what happens at the end of the rain season when the sun returns. For the first time in 6 months, the sun shines directly onto the forest. The result is an explosion in growth. For every leaf there is now, 3 more will appear in just 10 days. A wave of green crosses the continent. The migration of Bodele dust to the Amazon is just one of thousands of similar processes that distribute vital minerals to living habitats all over the world. This computer visualization shows the daily pulse of invisible gases oxygen and carbon dioxide in the air. But these vitally important materials are not produced by some geological process. They are made by trillions of tiny breaths far below. To see how it works means returning to the Amazon. This rainforest is about 55 million years old, one of the oldest living systems on the Earth. It is so biodiverse that half of all life calls this place home. A massive 5.5 million square kilometers of vivid green. In this case, the process starts in tiny holes on the undersides of billions of leaves. During the day, the leaf takes up carbon dioxide from the air. It converts the carbon into sugar and releases the volatile gas we call oxygen. Over the course of its life, a tree will release millions of cubic meters of this precious gas. Every day, the Amazon processes a fifth of the world's oxygen. For decades, it has been thought of as the lungs of the Earth. But now, satellites are helping to show that it's not quite as simple as that. The Terra satellite has recently observed that most of the oxygen the Amazon produces is reabsorbed into the forest at night. To release an excess of oxygen requires one more step. Two million tons of sediment washes from the rainforest into the vast Amazon River every 24 hours. The sediment drifts eastward 6,000 kilometers and into the Amazon Delta. Here, plankton in the water absorb the sediment, and with yet more sunlight and carbon dioxide from the air, the plankton population explodes once more. The bloom releases a pulse of oxygen so enormous, it can be seen from space. Half of all the oxygen in the atmosphere comes from plankton blooms. These tiny creatures are the real lungs of the Earth. It is they who maintain the precious balance of the air. This, in turn, allows the next link in the chain of life.